Industry skills, practical knowledge, real-world impact. This is Simple Gyan.
Every day, factories around the world produce not only products, but waste. Plastic runners from injection molding machines, copper wires from electrical industries, aluminum chips from machining workshops, rubber scraps from conveyor belt plants, e-waste from electronics factories, packaging waste, rejected components, dust, sludge, and offcuts. For many years, this waste was treated as a problem. It was stored, it was sold cheaply, it was dumped. Sometimes it was burned, and sometimes it simply became invisible. But today, engineering is changing the meaning of waste. Because inside this waste, there is hidden value. Plastic can become pellets. Metal scrap can become powder or feedstock. Rubber can become crumb. E-waste can release copper, aluminum, precious metals, and engineering plastics. Even mixed industrial waste can become raw material for construction, 3D printing, manufacturing, and energy systems. And the most interesting part is this. This transformation does not always need a giant recycling plant. Now, compact and intelligent micro-recycling machines are entering factories, workshops, and industrial zones. These machines can stand near the source of waste, process it locally, separate it, clean it, and extrude it. In this documentary, we will understand how these machines work and why they are the future of manufacturing. Part 1. What is micro-recycling? Traditional recycling is usually centralized. Waste is collected and transported to a large facility. This method works for many materials, but it has serious limitations. Transport cost is high. Material contamination increases. Mixed waste becomes difficult to separate. Small waste generators are often ignored. Valuable material loses quality. Micro-recycling tries to solve this problem by bringing smaller processing machines closer to the waste source. A micro-recycling unit may be installed inside a plastic molding factory, a machine shop, or an electronics repair cluster. It could be in a textile unit, a fabrication workshop, or even a rural manufacturing center. The idea is simple. Process waste where it is generated. When waste is processed locally, the material is cleaner, easier to identify, and more valuable. For example, if a factory produces only polypropylene waste, it is already sorted. A small grinder can convert it back into granules. If a shop produces aluminum chips, a briquetting machine can compress them into dense blocks that are easier to remelt. Waste is not moved as waste. Waste is converted into material before it leaves the factory. That is the heart of micro-recycling. Part 2. Why industrial waste has high value. Industrial waste is different from household waste. It is more consistent. A factory knows exactly what it is using. It knows the grade of plastic, the metal composition, and the process source. This means industrial waste is not just garbage. It is a secondary mine of polymers, metals, carbon, and chemicals. In rubber industries, conveyor belt scrap and tire rubber can be shredded into crumb rubber for surfaces and roads. Part 3. The basic architecture of a micro-recycling machine. It is a combination of many small engineering systems. The architecture includes a feeding system, size reduction, separation, cleaning, drying, and thermal processing. It also includes extrusion, cooling, pelletizing, and automation systems for dust, fume, and safety. 1. Feeding system. Waste enters through a hopper or conveyor. The feeding system must control the flow rate. 1. Feeding system. Waste enters through a hopper or conveyor. The feeding system must control the flow rate. 2. Size reduction. Large pieces are difficult to process. This is done using shredders, granulators, and hammer mills. The design depends on the material. Plastic needs sharp blades, while rubber needs high-torque shredding. 3. Separation. Industrial waste is often mixed. We use magnetic, eddy current, and air classification for separation. Electrostatic and optical sorting are used for polymer identification. Purity is essential for the final material value. 4. Washing and drying. For plastic, washing removes oil and labels. After washing, drying is critical. Moisture in plastic can create bubbles during extrusion. Micro machines use hot air or vacuum dryers to ensure quality. 5. Thermal or mechanical conversion. This is where waste becomes raw material. Plastic flakes are melted and extruded. Rubber is ground into crumb, and metal chips can be briquetted or melted in small furnaces. Quality is in the engineering. Part 4. Plastic micro-recycling machine. Plastic is ideal for micro-recycling because many factories produce clean scrap. Step 1. Sorting by polymer type. HDPE, LDPE, PP, PET, and others must be sorted. Mixing them can destroy quality. Even a small amount of PVC can degrade PT recycling. Step 2 is grinding, where rotating knives cut waste into flakes. Step 4. Extrusion. Flakes enter an extruder where a screw moves them through feed, compression, and metering zones. As plastic moves forward, it melts due to heat and shear. A screen pack filters contamination before the die. In one version, the plastic is converted into 3D printing filament for distributed recycling with additive manufacturing. Part 5. Cable and wire waste recycling. Electrical cables contain copper or aluminum and plastic insulation. Modern machines use mechanical separation. A granulator breaks the cable into metal and insulation particles. Air separation and density difference pull heavy copper from lighter plastic. The output is high-value copper granules. Part 6. Metal chip and machining waste recycling. In machining, waste looks like aluminum chips and steel turnings. These chips are bulky and oily. The solution is the briquetting press, which compacts them into dense blocks. Briquetting reduces oxidation loss during melting and recovers coolant for reuse. It is a win for the factory's circular economy. Part 7. E-waste micro-recycling. E-waste is complex, containing metals, plastics, and even precious metals. E-waste pre-processing includes component removal and enclosed shredding to handle hazardous dust safely. The output is a metal-rich concentrate. Micro-recycling upgrades e-waste for specialized precious metal refiners. Part 8. Rubber, tire, and conveyor belt waste. Rubber is vulcanized, making it difficult to recycle mechanically. Heavy-duty shredders with high-torque drives convert rubber into crumb for flooring, roads, and mats. Magnetic and fiber separation are used for conveyor belt scrap. The goal is a clean, usable raw material. Part 9. Advanced micro-recycling, chemical and thermal routes. Some materials cannot be recycled mechanically. Chemical recycling breaks polymers back into monomers. For PET, depolymerization converts it into building blocks. Thermal routes like pyrolysis use heat to convert waste into oils and gases. Safety and emission control are critical. Part 10. Sensors, automation, and smart control. Modern micro-recycling machines are becoming smarter. Sensors monitor motor current and pressure in real time. If a shredder jams, it reverses automatically for safety. And IR sensors identify polymers for high-purity sorting. This improves safety, energy efficiency, and consistency. In the future, machines will connect to digital material passports, making recycled raw material more trustworthy. Part 11. Economics: How waste becomes profit. Micro-recycling reduces disposal costs and raw material purchase. Reusing clean runners in production can save significant costs and improve a factory's sustainability targets. Part 12. Challenges and limitations. Micro-recycling is not magic. The biggest challenge is quality control. Recycled material must be tested for melt flow index, ash content, and tensile strength to be reliable. Metal briquettes need chemical composition checks. Without testing, recycling remains a scrap business. For a long time, industry was a straight line, but the future is circular. Resources are limited. Micro-recycling machines represent a new mindset. Waste is the beginning of another engineering process. The future factory may produce its own raw materials. Waste is just raw material waiting for engineering. Micro-recycling, small machines, big industrial revolution. Subscribe to Simple Guyane for more engineering documentaries.